Alrighty, guys, hello and welcome to the first Fly Science Guy Star Show. This show is going to primarily focus on things that you can see in the nighttime sky with your naked eye or a low-powered telescope, because not everyone has access to a big telescope, or not everyone kind of just does this as a hobby, so I want it to be accessible to everyone no matter what kind of equipment they have. So to start out the show, I want to first talk about something coming actually tomorrow night. So this is pretty instant gratification in terms of what you get to see, and that is what's called a lunar-Martian conjunction. Now, a conjunction is defined as two bodies sharing the same right ascension in the sky. Now, right ascension is how astronomers tell other astronomers where something is in the sky. So right ascension, if we were to put up a grid as so, right ascension are these vertical lines here. So you can almost think of it like Mars and the moon having kind of like a stick shoved through them, kind of like two cantaloupes. And they'll be very, very close in the sky. Declination, I'd mentioned declination, so I'll just full disclosure. The declination are the horizontal lines. So on the 6th of September, tomorrow, at 45 minutes past midnight, the moon and Mars will appear to be aligned in the sky. Now, conjunctions are not super rare. Well, for stars, their right ascensions don't really appear to change that much. For our moon, planets, and sun, their right ascensions do appear to change. But everything appears to go much, much slower than the moon in our sky. For instance, this is what our sky is going to look like tomorrow night, 45 minutes past midnight. If we were to go one more day ahead, let's see how far the moon here would move. So the next day at the same exact time, the moon is way over here now. The moon travels incredibly quickly across our sky, so it's not something that lasts super long, even throughout the night. But if you were to try to find Mars in the nighttime sky tomorrow night, you would say, oh, it's right above the moon. But if you tried to do that same trick the next night, you wouldn't have so much luck anymore. But I'll get back to that in a second. Literally every month there is a conjunction. With how quickly the moon appears to move across our sky, it will become aligned with at least everything, at least once in our nighttime sky in 1 month. So conjunctions themselves, they're not super rare, but what's really interesting about the lunar-Martian conjunction is just how close they appear to be. I haven't done this myself, but if you go out tomorrow night with a telescope and you point it at it, you might even be able to see them sharing the same telescope view, which, again, I haven't done it. I don't know exactly what it looks like, but I'm going to find out tomorrow night. So what's rare about this is that just how close they appear to be in our sky. Now, down in South America, they're going to see what's called an occultation, and that's when the moon moves directly in front of Mars. Now, I've only seen a few occultations in my life, only one that was really most memorable, and it wasn't really even with a planet. Occultations come from the word to occult something, which is to block it from view. And you can do an occultation with yourself right now. You just take your hand and get it really close to your face and just move your hand from left to right, or right to left. You can do it, doesn't matter, whatever hand you're using. Just move it across your face so you can't see your monitor anymore, and you've just made a monitor hand occultation. Lunar planetary occultations are far more rare. The view that South Americans are going to get around this same time is they're going to see the moon getting closer and closer and closer to Mars until the light just pops out of view. And then a few hours later, they see Mars pop out on the other side of the moon. Now, I think in our October show, I might bring up some lunar stellar occultations where the moon moves in front of stars, because that's far more common, and there are a few that I know might happen, but I'm going to have to do more research on that, and I'm going to do it. I'm going to talk about that in the October show. But I highly recommend going out to look at this, because just how close these guys get is pretty rare in and of itself. You're not going to really see the moon and Mars get this close together again until 2 years later, where they'll be even closer. It still won't be quite an occultation, but it's going to be even more incredible to see these two objects get just that close to each other. Now, like I said earlier about how this trick of finding Mars just by looking above the moon isn't going to work tomorrow night, all the things that I'm going to show you in this show, you're going to be able to see all month long. In terms of most of the things I'm going to talk about are planets that are up in the sky. So you're going to be able to see the planets all month long. Maybe not necessarily the phenomena that I'll talk about involving them, but it will be useful to tell you guys how to find planets without the aid of the moon, because the moon, quite frankly, is just not good for astronomy. It doesn't sit still, it's too bright, and it blocks out things with its light whenever it's closer to full moon phases. So I want to teach you guys how to find some of this stuff without the aid of the moon. So to find a planet, it should first be important to note the ecliptic. The ecliptic is the apparent path that our sun takes across the sky throughout the year. So here I brought up I don't want to blow you guys away, but there's going to be a lot of my artistic talents showing in this show. But here I have an illustration of the ecliptic going across some constellations. So the ecliptic is the apparent path that our sun takes throughout the year. Now they're a little small, but we have December 1st here, January 1st, February 1st, March, April, May, June. So these are the places that the sun would be at a given time of year. So December 1st, we would find the sun here in Scorpius, the Scorpion. You don't really have to remember these constellations too terribly well for most of what's happening this month. It's just for full disclosure of how the reasoning behind how you're going to find these planets. Next month, I'm going to go in a lot more detail about constellations, so I highly recommend seeing October show as well. But so December 1st, the sun would be here in Scorpius, the Scorpion. January 30th, you'll find the sun here in Capricornus, the Sea Goat. March 15th, you're going to find the sun here in, not March, but April 15th, you're going to find the sun here in Pisces, the Fish. But this isn't just the apparent path of our sun, this is also the close apparent path of our moon and planets as well. Let me bring up the ecliptic. We can see that I've brought up these 7 other colored lines. These are the orbits of our other 7 major planets, not counting Earth, of course, because we are standing on Earth, but we see that they keep a roughly neat line along the ecliptic, which is this red line here. So there are 2 questions you should ask yourself when you go outside and you see a bright light in the sky and you're wondering if what you're looking at is a planet or a star. And those 2 questions are, 1, is what I'm looking at in a zodiacal constellation? If what you're looking at is in a zodiacal constellation, it may be a planet. But if it's not in a zodiacal constellation, like Mars is in Pisces, then what you're looking at is most likely not a planet. So the first question, is it in a zodiacal constellation? The second question you should ask yourself is what I'm looking at twinkling? Now, we know the songs like Twinkle, Twinkle, Little Star, and we know that stars, the classic dictum is that stars appear to twinkle in our sky. But why is that? And why would planets not twinkle? Well, first to note is that stars are incredibly far away from the Earth. So if we have a star right here, and we have Earth right over here, starlight, or stars, are very, very far away, that by the time their light reaches the Earth, it's very spread out, and very little light actually reaches the Earth. And so that you can do the same thing for yourself if it's hard to imagine just from just trying to take my word for it. You can go out even tonight with a flashlight and point it in a direction where the flashlight isn't going to hit houses or trees or anything. Turn on the flashlight and you'll notice that the light disperses out, and the further it goes, the less it illuminates things. And so this same exact thing is happening with stars out in space. And that sunlight, when it tries to reach our eyes through our atmosphere, it bounces around all the water molecules and dust particles in the sky. Much like if you take a half-filled bottle of water and you stick a flashlight behind it and you shake up the bottle of water, you'll kind of notice that the light appears to dance around a bit as it gets reflected off this sloshing water. So that same thing that similar thing is happening with the starlight in our atmosphere. So it starts hitting our eyes in all different sorts of angles, and it makes it appear like it's twinkling. Planets don't appear to twinkle because they're a lot closer to us than stars are. Now, planets are still pretty far away from the Earth in terms of human scales, but they're way, way closer than any of the stars that you see in the nighttime sky. By the time the sun's light hits these planets and that light reflects off the other planets and comes back to Earth into our eyes, that light is a lot less spread out. So it's not as heavily affected by our atmosphere, so they don't appear to twinkle. So when you go out anytime this month and you look up and you're trying to figure out if what you're looking at is a planet or a star, if it's one, in a zodiacal constellation, and two, not twinkling, what you're looking at is very likely a planet. Now, the second thing that's going to be happening this month that's worth mentioning is another conjunction, like the lunar-Martian conjunction. We have a conjunction with the Moon and Venus, and that is occurring on the 14th. Now, the conjunction itself occurs about the same time as the lunar-Martian conjunction, but unfortunately, Venus and the Moon are not risen at that point. They're still underneath our horizon. So we are not going to see the conjunction, but as it rises up, it rises at about 3:30 in the morning, which isn't ideal, but if you're an astronomer, you don't sleep anyway, so it doesn't really matter. But if you're on your way to work, say at like 6 in the morning, you're still going to be able to see Venus high and bright in the sky. In fact, Venus is one of the brightest objects in the nighttime sky, so it's very, very hard to miss. When I worked at planetariums, people would come in, or they would call the planetarium, and they would ask about this strange bright object that was either in their evening sky or their morning sky. And they would ask, did I see a UFO, or what is this strange bright object in the sky? And if they said it was either evening or morning, it was very likely Venus, because it's so stunningly bright in the sky. And it's so stunningly bright because Venus is the closest planet to the Earth. So earlier when I said that more sunlight reflected off of planets reach Earth, it's even more so with Venus. So it appears extremely bright in the sky. Now, though it's not super as impressive as Mars, being not nearly as close to each other as the Moon and Mars will be tomorrow night, it's still an excellent telescope target, because you find out that the Moon is not the only thing that goes through phases. Venus is one of one of the two only planets in our solar system that appreciably go through other phases. When I say appreciably, I mean more noticeably go through phases like our moon. Now, to understand why Venus goes through phases, it's probably best to first explain why the moon even goes through phases. I forgot to bring up a little image. This is how Venus would look through a low-powered telescope right down here. You can notice if you don't have the video full screen, it's probably easier to notice this if you do full screen it. If you're on a phone, sorry, but you notice that that Venus through a telescope, you can kind of notice that it's kind of going through a phase right now, telling its mom that it's not just a phase, but it is. We notice that it's not a full circle. It's just kind of almost half of a circle. Here I just have a not a ground telescope, but an image taken with a probe for Venus, or a satellite. So it's a much better resolution. I just wanted to kind of show you exactly what Venus does look like. Venus is shrouded in a thick atmosphere of carbon dioxide gas, a potent greenhouse gas. It's called greenhouse gas because sunlight can easily pierce through these thick clouds around Venus. But when that sunlight hits the surface of Venus, it gets absorbed and re-radiated as lower energy light, or heat. And that heat, much like your car on a hot summer day, cannot get back out through this thick atmosphere, so that heat gets trapped in Venus. And then more sunlight comes in, and that turns to heat, and that gets trapped, and it builds and builds and builds until we have Venus at the temperature it is today. Nearly 900 degrees Fahrenheit, day and night. Hot enough to melt lead. Americans are actually pretty bad at landing anything on Venus, because Venus is incredibly hostile, not only being very hot, but also rains sulfuric acid. So I don't recommend vacationing to Venus. But the Russians were actually pretty good at landing on Venus, and now that I come to think of it, I kind of wish that I had gotten the image from their probe before the show. But maybe I'll post an image of what I'm about to talk about after the show. But the Russians were a lot better on landing on Venus than Americans were, and their probe lasted for about 20 minutes taking pictures and taking data before Venus melted circuitry and just completely ruined the probe. So it's an incredibly hostile environment. But it's an excellent telescope target, not as go back on a more optimistic train. So, like I said, it's probably best to explain why Venus has phases by first talking about why the moon has phases. The moon orbits around the Earth, and so at different points in its orbit, we see different parts of the moon lit up by our sun. So when the moon is right about here, this red dot is our perspective, by the way. So we're looking out in this direction. When the moon is here in its orbit, we see it in what's called a first quarter moon. We see it kind of half lit up and half darkened, separated by what's called the terminator. When the moon moves further in its orbit to be right above our perspective, it is in a full moon phase. When it's here in its orbit, third quarter, and when it's in between us and the sun, it's called a new moon, meaning that we don't see any of the lit up parts because the lit up part is obviously pointed towards the sun, and we would be looking at the dark side of it. Now, new moons occur. You wouldn't see the moon any time at night if it was in a new moon phase, because it is between us and the sun. And so the only time we see the sun is during the daytime. And during the daytime, when everything's lit up, you can't really see the moon all that well, and you certainly can't see any stars. But I'm sure at some point in your life you might have seen the moon up during the daytime, and that was likely when it was in first quarter or waxing crescent, or if it was in a third quarter or waning crescent, when you would see the moon and the sun share the same part of the sky. So the moon goes through phases because we see it at different perspectives, both further out from us, from the sun, so we see more of it lit up, and parts further when it's in between us and the sun, so we see more darkened parts. So Venus, though it's always at a closer orbit to the sun than we are, goes through phases because it does get in between us and the sun. So here we have a top-down perspective of Venus as it goes around the sun. We can see how it's lit up differently from a top-down perspective, and then we have Earth's perspective, and we see it going through different phases. So when it's around here-ish, we see more kind of it half lit up, and as it gets closer in between us and the sun, we see more of the darkened back half of it. As it goes out this way again, we see more of it lit up again, and we don't quite see a full Venus, because the only time we would really see a full Venus is when it's on this side of the sun, and at that point the sun is usually in between us and Venus. But so you get to see Venus and the moon share different phases with each other when they're both up in the sky. Now, at this point, on the 14th, if you had a low-power telescope, you'd probably just barely be able to make out that Venus is in a phase. But at this time, around we'll even it out and say 4:30 in the morning, the moon will be in a waning crescent, meaning it's getting darker and darker, closer in between us and the sun. And Venus, if you put a telescope on it, you'll notice that it's in a waning gibbous, meaning that it's getting in a point in its orbit where it's going to get in between the sun and us. So if you point a telescope at Venus, it's probably gonna look a lot like what this shot of Venus looks like. Kind of a half-lit dot in the sky. Not quite a full sphere, but almost like an egg or a teardrop shape. So you're going to be able to see that on September 14th. And later on, we have another planet that's going to show up in our sky. Now, this one is a bigger deal. Because this is a very elusive planet. You hardly ever get to see this unless you're really trying to look for it, and that is the planet Mercury. Now, the best times to see Mercury this month are the 19th of September and the 28th of September. Now, when we talk about the best times to see planets, there are different points and different terms that we use for planets that are further out from us, from the sun, and different terms for planets that are closer to the sun than us. Now, planets that are further away from the sun than us are called superior planets, and planets that are closer to the sun than us are called inferior planets. So I'm going to try to quickly just draw something here. We have Mercury, which has its closest orbit to the sun. We have Venus, which is the second closest planet to the sun. We have Earth after Venus. We then have Mars, Jupiter, and Saturn. So whenever we have a superior planet in its best view, that is when it is on the opposite side of the Earth from the sun. So one of the best times, if you wanted to see the moon, one of the best times to see it is when it's in a full moon, which when I showed you the different phases of Venus, that is when it's in a full moon and it's fully lit up. So that same premise is for here. So the best time to see a superior planet like Mars, Jupiter, or Saturn is when it's in between, or when it's on the other side of us from the sun. So it's fully lit, and we're at one of the closest points that we could be to it in an orbit of any given year. But for inferior planets, it's a little bit different, because it wouldn't be ideal to see Mercury or Venus whenever it's in between us and the sun, because then, the sun's bright. You don't want to look directly at the sun, and you wouldn't really be able to see anything anyway. Whenever a superior planet is on the other side of the Earth, it's called opposition. But the best time to see an inferior planet is at a time called greatest elongation. Now, greatest elongation is when it is at its greatest, when it's elongated furthest from the sun. So here, greatest elongation occurs whenever the Earth, inferior planet, and the sun make a right angle triangle with the inferior planet at the right angle, because this, to our perspective on Earth, would be the furthest that it would appear from our sun throughout the year. But just because this is the furthest it would be from our sun from our perspective doesn't mean it's the best time of year for us to view it. So the best time of year happens to be on September 19th, where Mercury is here in its orbit and the Earth is here in its orbit. So if we were to make a triangle now, we would see that it does not make a right triangle with the Earth, planet, and Mercury. It might kind of look like a right triangle with the sun at the right angle, but not with Mercury. So it's not greatest elongation, but this is one of the best times to see it this month. So at this time, September 19th, Stellarium seems to think that the best time to view it would probably be around 7:36, because this is when you notice Mercury more. This little speck right here is Mercury. Now, I know, it doesn't look super impressive. It's not really spectacular. It doesn't look really bright and red like Mars would. It doesn't look super noticeable like Venus or Jupiter, but it's a big deal because Mercury doesn't stick around for very long. Mercury, in fact, was named after the Roman god, or the Roman messenger god, Mercury. He was one of the fastest gods in Roman mythology, and is why the Greco-Roman societies gave this planet the name Mercury. It's very, very fast. It orbits around the sun in about 88 days. That's, contrast to the Earth, that takes 365 days. So that's more than 4 times faster than the Earth goes around the sun. So Mercury doesn't stick around for very long. So this is the 19th that we see it. Another good day to see it is the 28th. And the reason these are good days to see it is because these are the days that it appears highest above our horizon. Now, like I said, these aren't the days that it's furthest away from the sun, but that doesn't matter because this is the point where we have the greatest window of opportunity to see Mercury. So this is what the orbits would look like on the 28th, and to give you an even better idea of just how fast Mercury moves, this is how far Mercury appears to move in 9 days compared to how far the Earth appears to move, which is drastically faster. And so they appear to be about, on the 19th, we would see Mercury closer to the west, just kind of diagonal from the moon on the 19th. And on the 28th, it's a little more southward, but it's still high enough above the sky that this is probably the longest you'll get to see it. But you really have to go out at this time, because 15 minutes later, on pretty much both days, Mercury will set. So you have 15 minutes to go out and find Mercury. Now, like I'm showing you here, you'd want to look to your west, a little kind of west-southwest on the 19th, and then more southwest on the 28th. And just to give you a contrast, on October 1st is the actual greatest elongation, which is just 3 days after the 28th, and we would see Mercury. I tried to give it its best shot by making it a time earlier than on the 28th, but we see that it's significantly lower in the sky and more southward. So even though this is the day of greatest elongation, it is not the best day to see Mercury. That is again on the 19th and the 28th. And finally, one of the more impressive things to see in the sky, especially if you have even just a low-powered telescope, occurs on I believe the 24th. Yes, 24th and 25th of September. So in between these two times to see Mercury, go out on the 24th and 25th at pretty much, you can just go out after sunset to see this. And you'll find the moon, the Jupiter, and Saturn all within the constellation of Sagittarius. Sagittarius is easily found by kind of looking for a teapot in the sky. Now, again, this video will stay up on the Facebook page, so you can always reflect back on this video throughout the month to help you find some of these other things. But again, October is when I'm really going to teach how to find constellations, how to remember them, and the importance of them. But so Jupiter and Saturn will be pretty high up in the sky around sunset on the 24th. And there's not really anything super spectacular going on. You're not going to see any conjunctions on the 24th or the 25th because they'll both have happened before you can even see these objects. But the reason that you want to go out and see these are because this is a good time where you have 3 excellent telescope targets all up in the sky at once. Jupiter is Jupiter is a great telescope target, not quite because you get to see features on Jupiter. You would need a slightly more powerful telescope to see features like the bands of clouds on Jupiter or the Great Red Spot, which is a giant hurricane essentially on Jupiter that's been raging for 300 years. It's not quite that easy to see with a low-powered telescope, but what you will see around Jupiter are its moons. When you point a low-powered telescope at Jupiter, you'll be able to see the 4... Most of the time, you'll be able to see the 4 Galilean moons. Now, these moons of Jupiter got the name Galilean moons because they were first discovered by Galileo Galilei, one of the first people to apply telescopes to affirming the heliocentric model of our solar system. That is, that the planets, Earth, and the major planets revolved around our sun rather than the pre-Copernicus geocentric models that people said that everything revolved around the Earth. Whenever Galileo pointed his telescope at Jupiter, he noticed these little moons around Jupiter. And at first, he thought that they were stars, but he kept pointing his telescope at Jupiter every single night that he could, and he would notice that these dots appeared to be in vastly different places around Jupiter at different nights. Io, which is one of the closest moons to Jupiter, orbits it in less than 20 hours. There are times that I've gone out and done kind of stargazing parties for people, and I would be pointing out Io towards the beginning of the night, and before the end of the night, Io had gone around the other side of Jupiter. And so he noticed that all these dots were moving around Jupiter, and he said, now hold on a second. If these objects are orbiting around Jupiter or appearing to move around Jupiter, then they're obviously not moving around the Earth, so clearly everything in the universe is not orbiting around the Earth. And so Galileo Galilei, this information really cemented in people's minds that everything in our solar system, in terms of the planets and asteroids and such, they orbit around the sun, not around us. Saturn is also another great telescope target because even with a low-powered telescope, you'll be able to see the rings around Saturn. I have this like really dinky telescope, barely bigger than a Pringles can, and I was able to go out the other night and still be able to discern the rings around Saturn from the sphere of Saturn. In fact, Galileo Galilei also looked at Saturn when he was using his telescope to study the sky and space, and at first he called Saturn a planet with ears, because Galileo didn't really have a great telescope. At that time, astronomy was pretty much consisted of people looking at stuff like this in the sky before telescopes were bigger or more complex. So at first he called it a planet with ears until he deduced that these rings are actually super itty-bitty tiny microscopic dust and ice particles also orbiting around Saturn. So these rings aren't solid. These aren't solid rings. There's just millions of little dust and ice particles circling around Saturn to make it appear that it has very obvious rings. Now, the rings around Saturn extend out from the sphere of Saturn about 175,000 miles, almost as far away from as the Moon is from the Earth. But though they extend out that far, they're actually only a few yards thick. If you're a Pittsburgh native and you've gone to Heinz Field to watch football, if you were to shrink Saturn down to the size of Heinz Field, the rings would be thinner than a piece of paper. If you don't know how big Heinz Field is, another comparison I made was when I worked at, when I did more work at the Pierce Planetarium. The Pierce Planetarium is about 40 feet wide. And if you were to shrink Saturn down to the size of 40 feet, these rings would be thinner than a human hair, almost by 1,000 times thinner. And of course, anytime I talk about Saturn, the thing I always want to mention about it is that Saturn is our least dense planet in the solar system. And so when I say it is our least dense planet in the solar system, it means that for its size, it's a lot lighter than all of the other planets. If you were to get a really gigantic bathtub, I'm talking planetary-sized bathtub, and you filled it up with water and you plopped Saturn inside of it, the entire planet of Saturn would float on the water, making it like our solar system's very own personal rubber duck. So these are some of the things that you can notice in the sky with a telescope or just by going out and looking at them. But one of the more interesting things going on in this month is the autumnal equinox. Now, the autumnal equinox is the point where the sun is centered directly over the Earth's equator, so that we have an equal amount of day and night. Equa meaning equal, nox meaning night. Equa, nox, equal, night. And this gives way to why we have seasons. Again, thank you. I know I blow you away with my artistic talent. We see that the Earth orbits around the sun in a counterclockwise motion. Our Earth is also tipped on its side about 23.5 degrees. So there aren't many times throughout the year that the entire Earth gets the same amount of day and night. During the summer solstice, where the sun is highest in our sky, the northern hemisphere where we live is pointed towards the sun. So more of the sun's light ends up hitting the northern hemisphere. So we have more direct light, we have more direct light for longer periods of time, and we get heated more efficiently. During this time, we also have less nighttime because most of the hemisphere is lit rather than not. In the southern hemisphere, where Australia is, for instance, they would have winter at this time because they get less direct sunlight. They get it for a less amount of time, and it is darker more than it is lighter throughout the days. An interesting thing is that, you know, when I was in elementary school, one of the things I thought was it was winter when the Earth was further away from the sun, and it was summer when the Earth was closest to the sun. But actually, it's the opposite. During the summer solstice, the Earth is the farthest point away from the sun that it gets in its orbit. During the winter solstice, where it's winter time for us in the northern hemisphere, we are actually at the closest point to the sun in our orbit. So during the winter, we are closer to the sun, and during the summer, we are further away from the sun. So that is not an indicator of why our neck of the woods is hotter in the summer and colder in the winter. It all has to do with how much of the sun's light is hitting our hemisphere. So during the equinox, the sun's light is directly above our equator, because our Earth doesn't change the way it's tilted in its orbit. It's always pointed in the same direction. So if here it's we get more light in the northern hemisphere, and in the winter solstice we get less light in the northern hemisphere, at the equinox it is right above the Earth's equator. So the northern hemisphere and the southern hemisphere get the same amount of light for the same amount of time. And this created all sorts of different festivities for cultures all around the world. Astronomy is one of the greatest ways to connect with cultures from different parts of the world, and different periods in time. No matter where you are on the Earth, you are seeing the same night sky as anyone else would see, and for the most part, the same stars as our ancestors looked at. The stories they told and the festivities they had may be human and stuck on Earth, but many of their inspirations came from the same stars that we see today. And our descendants will see 1,000 years from now are the same as well, pretty much. Now, something more close to home about cultures that celebrate these changings of seasons are, for instance, the Christians. We're often taught that the equinox lies on the 21st of May and September. The 21st of September and May is called the ecclesiastical, autumnal, and vernal equinox, respectively, or the fall and spring equinox. To say the ecclesiastical equinox is to say the equinox as recognized by the Christian Church, which is a fine enough approximation, but it's not the rule. Earth undergoes many complicated motions, lending itself to a lot of apparent inconsistencies here on Earth. For instance, the equinoxes and solstices don't occur at the same time every year, especially with calendars such as our Gregorian calendar, what we use every day of our lives. Since there are Christian holidays that are marked by these astronomical happenings, they needed a little more reliability, at least as much reliability as they could get. Now, since Easter is marked by the Sunday following the first full moon, following the equinox, things could get pretty chaotic in terms of annual Easter dates. For instance, a couple years ago, I was writing an article for the Pittsburgh Post-Gazette about the equinox that year, and I wanted to talk about its ties with Easter, and expected it to fall on the 22nd of March, the earliest day that Easter can occur. But there was a full moon that followed the astronomical equinox, but everywhere I looked, Easter was not until April 16th, one of the farthest days you can have Easter from the equinox. This was when I learned that the church had its own set equinox. So since the full moon was the day before the ecclesiastical vernal equinox, or the equinox as dubbed by the Christian church, we had to wait an entire month's worth of time for there to be another full moon to occur, which then led to the Sunday following that being Easter. So instead of working with two constantly changing variables, where the sun is and where the moon is, they decided to just go with one, the movements of the moon. So they set the fixed ecclesiastical date for the equinox and solstices to be the 21st of their respective months. That is, September 21st being the ecclesiastical fall equinox, March 21st is the ecclesiastical vernal equinox. You're very welcome, Eric. The December 21st being the ecclesiastical winter solstice, and June 21st being the ecclesiastical summer solstice. But there are a ton of other cultures that celebrated holidays based on astronomical happenings as well. The Greeks and the Romans, this wasn't too much of a celebration, more than it was a story for them to make sense of the world around them to them and their children. Now, the Greeks told many stories about gods and goddesses to help make sense of the world, and one particular story involved a goddess named Demeter, goddess of agriculture, and her daughter, Persephone, goddess of spring. The legend says that Persephone was kidnapped by Hades, which was the god of the underworld to them, and Hades forced Persephone to marry him. This obviously upset her mother Demeter so much that she made the earth barren and unable to grow vegetation until Hades returned Persephone to her. Now, this didn't suit well with Zeus, god of gods, so Zeus declared that Persephone would be with her mother for half of the year and with her, air quote, husband, Hades, for the other half. Now, this legend explains that Persephone is with Hades until the vernal equinox, or the spring equinox, where she returns to the earth to be with her mother, giving joy to Demeter, goddess of agriculture, who she then gave life to the earth. Then when the autumnal equinox rolls around, Persephone returns to the underworld and her mother returns to her grievous state, leaving crops to wilt and die. And this is how Greeks and Romans remembered that they needed to get their crops picked before their idea of Demeter killed all the crops. They had to get those picked beforehand, and then they knew when it was a good time to start planting crops again, which was during the spring. Now, it should be understood that this was far before women's rights, and whilst the Greek legend was sympathetic towards Persephone's mother, they weren't as sympathetic toward Persephone and her illegitimate marriage. And it should be understood that all cultural stories and all different cultures reflect what was socially acceptable at the time to that culture. Even our cartoons, television shows, and music may seem barbaric to generations in the future. Now, everything that these festivals and stories that, or at least the Christian and Greco-Roman societies that I talked about so far, are all Western societies. But there were some Eastern societies, and still are, that celebrate the equinox in a different way. These Asian cultures, Eastern cultures, they go by a different calendar for their celebrations. The Chinese lunar calendar. The Chinese have a festival called the Mid-Autumn Festival, and this is on the 15th day of the 8th month of the Chinese lunar calendar. It's a calendar based on the phases of the moon rather than the days of the sun. So the autumn full moon has been celebrated by the Chinese since the Shang Dynasty, about 24,000 years ago? No, 5,400 years ago, I believe. It was between 1600 and 1046 BC. The first mentioning of the Mid-Autumn Festival first appeared in the Rites of Zhao, a written collection of rituals from the Western Zhao dynasty, which was about 600 years after the first marked celebration of any autumn full moon that they talked about. Now, there's a lot of emphasis, or there was a lot of emphasis on moon worshipping in these festivities. It was popularly a time to celebrate the successful harvest of rice and wheat with food offerings to the moon. But today, the Mid-Autumn Festival is an occasion for uniting with friends and family and eating moon cakes made out of lotus seed paste and watching the moon. The Japanese and the Koreans had a more Buddhist origin for their celebrations of autumn. For Japanese, they had something called Ohigan, and this occurred on the 12th to 18th day of the 8th month of the Chinese lunar calendar. And it was a time to visit ancestors, honoring them and nature. In Japanese Buddhist traditions, crossing the mythical Sanzu River meant passing into the afterlife. And people thought of this period as a time of bliss, as they believed it was the closest they could get to the afterlife and nirvana without dying, of course. During my research for this, I discovered a really interesting flower. Now, this isn't really necessarily astronomy, but it's science, and I think it's cool. There's a flower specific to this celebration called the Higan Bana, which means the flower of Higan. It's a red spider lily that grows around the time of Ohigan. It's also known as dead flowers or ghost flowers, allegedly because they grew a lot around graveyards. But it's not that they grew specifically around graveyards, it's because the Japanese would plant these around graves because there was a mild poison in the roots of these flowers that kept bugs away from their family, as depressing as that may sound. The Koreans had a Buddhist tradition called Chuseok. This occurred on the 14th to 16th day of the 8th month of the Chinese lunar calendar. So they're all centered around this idea of the Chinese Mid-Autumn Festival, but it might not have directly come from that, but humans are often inspired by similar things. And so if we notice similarities between cultures, it's because we're all human and we all live on Earth, and we're often stimulated and inspired by the same things. So we tend to, make up similar traditions because, we're all human, we're all the same, and we're just kind of experiencing life in the universe together. So their belief was, or popular belief says that Chuseok came from Gabe. And Gabe started during the reign of the third king of the Kingdom of Silla between 57 BC and 935 AD. It was a month-long weaving contest between two teams. On the day of Gabe, the teams who had woven the most cloth would be treated to a feast by the losing team, which I thought was cute and very wholesome. It's said that weaving competitions, archery contests, and martial arts demonstrations were held as a part of these festivities. But many scholars believe that it probably originated from ancient shamanistic celebrations of the harvest moon, this is where the Korean beliefs and the Japanese belief kind of coincide, because this tradition have them returning to their hometowns to pay respects to ancestors and deities with new harvests. And this reflects many Asian traditions around this time. Now, going back more to Western societies again, the Roman paganistic religions had a festival called Mabon, and this was a feast on the autumnal equinox. This kind of almost harvest festival-esque celebration was to celebrate the gifts from the earth. It was later adopted by the English in the form of harvest festivals, which then was used as the basic idea for American Thanksgiving. Now, though Thanksgiving is celebrated in November, it has a lot of parallels with these older harvest festival traditions. The Mayans had something called the Descent of Kukulkan. Each equinox, a show representing the serpent-like dragon Kukulkan, is thought to return to the Earth, and this was via a temple called El Castillo down in South America, where it was built in such a way that the shadows casted by the temple on itself made it look like a serpent was descending the temple to commune with his worshippers via religious speakers and to provide blessings for a full harvest and good health before entering the sacred water, the sacred cenote, bathing in it and continuing on its way to the underworld. And though this last one isn't really a tradition, it was something that I found was pretty interesting. The French Republic, during the French Revolution, created a new calendar. And each new year started at midnight on the day of the autumnal equinox, presumably the ecclesiastical equinox, the 21st, to make things simpler. This was an attempt to remove religious and royalist influences from the calendar, with each month being named after a natural element. And the French followed this calendar for about 13 years, between 1793 and 1806, before it was abolished by Napoleon Bonaparte. And so cultures have all these different ways of celebrating the same thing. And though though fall leads to darker and colder times, we as humans still found ways to celebrate it and give life to the life and warmth to the oncoming colder seasons. Now, though it is colder, winter and fall are better times to actually go out and see stars and do astronomy, because as we get closer to winter, the nights become longer. So there's more time to go out and look at the stars because it's darker longer, but also because as the temperatures get colder, there's less moisture in the air. So earlier when I was talking about the sun's light, or the star's light, bouncing off of the water molecules in our atmosphere, when it gets colder and there's less moisture, there's less of the light to get obscured by. So there's more direct starlight in our eyes, so things are a little more focused and easier to see with telescopes especially. Now, there is one last thing that is worth mentioning. It's the zodiacal lights. So this is something that I didn't even really know about until I started doing research for this month's show. And the zodiacal lights is a phenomenon where you have to be in an extremely dark area. And I don't mean just a few miles out of town. I mean you have to be in a really dark area to see the zodiacal lights. And what the zodiacal lights are is they look like a pillar of light coming over the horizon, either just after sunset or just before sunrise, depending on the time of year. Now, the best time to view the zodiacal lights is when the ecliptic makes the highest arc in the sky. Now, during the fall months, the best time to see the zodiacal lights are in the early morning. So I'm going to move us further in the morning, and here we have the ecliptic again. So we see that as we get closer to sunrise, the ecliptic gets steeper and steeper in our sky, and this is what you want. So around this time, around 3 o'clock probably, you would start to see a pillar of light slowly coming higher and higher in the sky. And for a while, people really didn't understand what was going on. It was really cool, but they didn't really know what was happening. It was kind of off-putting to them. It was later on that we found out that what was going on to create this apparent pillar of light was that there are super fine, super tiny, microscopic dust particles floating in our neck of the solar system. And they all exist in the plane of the ecliptic. The moon, planets, their moons pretty much lie along the ecliptic, as we saw earlier in the show, and so do these small dust particles. So during sunset or before sunrise, the sun's light bounces off of all of these dust particles surrounding Earth in our part of the solar system, and we see that reflected light on Earth in the form of a pillar of light coming over the horizon where the ecliptic is. And so during the fall months, the point where the ecliptic makes the steepest angle in our sky is during the morning. But if we go to, say, I messed up. Hold on a second. I need to go back. Okay, September. I was doing months instead of time. So earlier in the morning, just before sunset, we would see the pillar of light. But during the springtime, starting probably around January, I know this is kind of actually the, let's go to like March, April. During this time, the ecliptic makes its steepest angle in the evening. So during spring, we would see the zodiacal lights over in our western horizon in the evening just after sunset, and during this time of year, in the fall, we would see its steepest angle in the morning just before sunrise. Now, again, I don't want to get too many hopes up, because you do have to be very far away from Pittsburgh. I recommend, if you live in Pennsylvania, which probably most of the people watching today do, I recommend Cherry Springs. It is what's called a designated dark zone specifically for astronomy, where there are no lights for miles, and you just get to see an almost completely unpolluted nighttime sky in terms of light pollution. Another really interesting thing about the zodiacal lights is that Brian May, the lead guitarist of the band Queen, did his PhD astrophysics doctoral thesis on the zodiacal lights. Yes, the lead guitarist of Queen had a doctorate in astrophysics, and he did his thesis to get his PhD on this very phenomenon. And I'll post. I'm not going to say that it's an easy read or a read that many people would do for fun. If you're trying to get to sleep at night, it might be a good read. But I will post his if not, well, we don't have access to his doctoral thesis, but we do have access to other papers that he co-wrote, and I'll actually put one of those up because I just think that's cool. So with that is the end of our show. Okay. So I want to thank all of you guys for joining us. I hope that you guys come back and learn more. We have, I hope the show inspired you to go out to look at these happenings for yourself this month. While things like the lunar-Martian conjuncture will only happen on specific dates at specific times, the planets that I talked about will be visible all month long from your own backyards. My fiance and I appreciate all the enthusiasm that we received for this show, and we want to keep doing these live streams for you. So let me know by messaging the Fly Science Guy Facebook page what you liked, what you didn't like, what show topics you would be excited to see in the future. And of course, if you feel so inclined and have the means to do so, there's a donation link on the Facebook page, and those donations will help us be able to keep making the shows and improve the quality of the shows in the future as well. Now, I'm going to open the floor for any questions that you guys may have for a little while, and I encourage you guys to come back, learn more, never stop asking questions about space and science and the world around you, because there is so much that we don't yet know and so much that we can all still learn together. So again, I hope you guys, I'll be sitting around for a little while. to answer any questions that you guys might have. You guys are all very welcome. I'm so happy and so touched that you guys came for the show, and I hope that it was educational enough. I hope that it was succinct enough to appreciate and be able to go out and apply some of these things yourself. Again, I can't overstate how much I recommend tuning in for the October show. This was a different format than I usually do. Most of the time, I usually do shows specifically about finding constellations and the history behind constellations. There's a little more emphasis. Well, no, I don't know if there's a little more emphasis on archaeoastronomy, which is the study of how other cultures did astronomy. But it's a great time to learn how to trek across the nighttime sky, almost like learning how to read a road map. And once you get used to the nighttime sky and you're able to navigate the sky like you would a road map, things get way more easy to find and learn about in the sky because you have that kind of background. And I love doing those shows. So since you live in Indiana, 7 hours away, is the nighttime sky that you see any different now from what you guys see in Pittsburgh? No. So the way that things kind of work is that here on Earth, we do things. We live in about this area of the world. So here's us, like right here, and 7 hours away is barely even me moving the mouse. So we live in a part of the Earth that's about what's called 40 degrees latitude on the Earth. And latitude is just how far above or below you live from the Earth's equator, the imaginary center line that splits the Earth in halves. So we live about halfway up in about this region. This is about 40 degrees latitude. Pretty much everything that you would see in Pittsburgh, you would see pretty much the same exact thing even down in Florida. This show is pretty much applicable everywhere in the United States. And honestly, in reality, here's like China, Japan, Russia-esque area. They would see pretty much the same things that we see in Pittsburgh. Not at the same time, obviously, because they're on the other side of the Earth, but when it gets night for them, they would see the same exact stars, constellations, planets that we'd see at night as well. So, pretty much my shows are good for almost anyone in the Northern Hemisphere. Once you get further down into the ecliptic, you start losing certain things, but most of the show is still pretty appreciable. So your nighttime sky 7 hours away from Pittsburgh is not going to even look any different at all. So it's still super applicable to all over the place in the United States. Fantastic question. Did you have anything to interject, sweetheart? Yeah, I did mean equator. I did not mean ecliptic. The equator being the center line that separates the Earth in halves. That was a slip. That's what astronomers get whenever the astronomers before me make so many things sound similar to each other. You're very welcome. I'm so happy that you enjoyed it. If anyone ever has any comments about, it doesn't even have to be about the content necessarily, but if you have any like suggestions about things you'd like to see different with graphics or sound or anything like that, feel free to message the Facebook page for that too. Really, nothing is barred. No suggestion is barred. All of it is super helpful and super appreciated. What?
Like, Mercury. I said, what if I live like in a valley? That change it? Should I go some elevate?
So her question is, with Mercury being so not easy to find and not in a very fleeting sight, does living in a valley make it more difficult to see it, and would it be set already beforehand? Depends how deep the valley is. If you live in a crater, yes. Like, if your vision is obscured from the horizon, yeah. But for the most part, unless you're surrounded by really tall mountains that are really close to you, you'll likely get a view of Mercury before it sets. And the second part of that question is, would you need to be up on a higher elevation? No, but it is helpful because, well, I don't know if it's really that much helpful. So the thing about the Earth is that, obviously, it's round. Don't let anyone tell you it's not round. And one of the ways you can test this as well is if you, say, go to, what is it, the Chrysler Building in New York, for instance? The really, really tall building in New York, right? And you watch the sunset out in front of the building. And then you go in the building and you take the elevator all the way up to the top floor, you could watch the sunset again. Because you're now looking at the sun again from a better angle. From an angle where, like, the curvature of the Earth isn't blocking it anymore. So that's another really good emphasis on why the Earth is very obviously round. Oh, you're welcome, Tammy. I love the mythology part of it. I was like, archaeoastronomy is one of my favorite things on the side of astrophysics and astronomy, because it's like, it's really cool. Like, it's great to see stars, and it's great to, like, know how they work, but there were other people far before us that looked at the stars and such as well, and they didn't necessarily have the same understanding of the stars, but they still made stories, they made celebrations around it. There were some cultures that had a pretty good understanding of astronomy. One of my more favorite cultures was actually a Native American culture called the Pawnee Indians, or Pawnee Native Americans, and they were heavily involved in astronomy. They made star maps that represented the nighttime sky. They had huts that were made specifically for astronomy, and the huts were designed by astronomy as well. These huts had 4 different posts that held them up, and each post represented a different star. That their belief was that these stars held up the sky. And these posts were different colors. They were yellow. I believe they were yellow for Capella. They were red for Antares. They were black for Sirius. And I can never remember what the white one was. But they thought that these stars held up the sky, and so they made these poles that represented the stars holding up their huts that they used for astronomy. And it's really interesting because, like, there were a lot of different cultures that drew constellations a similar way to the way that we draw them today, or that the International Astronomical Union agrees on. But there were also different... No, yeah, it might be Vega, actually. You might be right. Look at you go, Rachel. Rachel and I used to sit in the planetarium all the time and just look at the stars roll by. but they drew a lot of constellations the same way as the standard way today, but they also drew them a lot differently as well. In fact, I didn't really intend on showing this in the main show, but there was I do talk about this more in the astronomy shows that I'm gonna like what I'm gonna be doing in October, but I need to go through all my documents to get to it. But especially Eastern cultures had different perspectives on astronomy than Western cultures did. Most of the constellations that we use today came from Greco-Roman societies, Western societies. But the East also did a lot with astronomy as well. Here is a star map from China a long time ago when a guy named Shen Kuo did a lot with astronomy. In fact, Shen Kuo existed a long time before Copernicus did. Copernicus was the guy who first, in the Western world, suggested in literature that we had a heliocentric model, meaning going around the sun, rather than geocentric model going around the Earth. But Shen Kuo lived far before Copernicus and discovered the same thing, that we went around the sun rather than the sun going around us. And this is one of the star maps that he ended up making. And we can see that, or we will see in the October show, that these constellations are drawn way differently than the Western societies drew theirs. But there are some similarities. Like right here, we can see... Oh, it's the wrong thing. Right here, we can see this is very apparently Orion, the hunter. And so if this is Orion, then that means up here is Pleiades. Right here is Taurus's face, right here. So if that's Taurus's face, this right here might be the North Star at their time, I believe. So it's just really interesting because people all over from different cultures studied the stars in different ways, and they had their different perspectives on them. But even then, they're all the same stars, you know? It's just incredibly interesting to see the way that to see different perspectives of how people view the world. It's probably one of my most favorite things about astronomy, because we have so much documentation about all these different ways that people saw space and stars. Think about 80 years ago, maybe? Yeah, it wasn't that long ago before the International Astronomical Union said, this is how we're going to see the night sky. I think it was like 1922 or something like that. That's when we standardized the nighttime sky with the constellations that we agree on today. So it wasn't that long ago. But mostly because we came from the Western world, and because our culture came from mainly the Greeks and the Romans, most of the constellations we see up there were already pretty much being used. Because the Eastern societies did a lot with science and astronomy, but we belong to a Western culture, so we mostly used that. And I don't really know the history of why we stuck more with these constellations that we do, but there are still some Japanese, Chinese influences in the southern hemisphere as well. And we see the contrast between mythological constellations in the northern hemisphere that we see compared to modern day constellations in the southern hemisphere when the Western world started traveling more around the world.
What was the website? All of these.
So the program that I'm using right now is her question was what app am I using right now? And right now I'm on my computer. And the great thing about this application that I use is that it's both for the computer and for your phone. It's called Stellarium. There is a free version of it on Android, so you can go out, and it does have an option to do GPS navigation with it. So you like point your phone up in the sky, and it'll try its best to tell you what you're looking at. It's not perfect, but it's pretty close. So that's Stellarium. And I highly recommend it. I use it all the time. Even when I don't do these shows, when I used to do shows in planetariums, I would plan out my shows by using Stellarium because it was so useful and helpful. But yeah, it seems like we're probably mostly out of questions. So I want to thank you guys again for coming to the show. Please do message and tell us what you did like about it, what you didn't like about it, and any things that you'd like to hear about in future shows. So thank you so much for coming, and I hope you have a wonderful rest of your evening and month. And I hope you go out and see some of these things. Remember, tomorrow night at midnight is the first thing I talked about, the lunar Martian conjunction. So thank you so much, and have a good night, guys.